Have you calculated telescopic crane boom stresses? One of the most popular types of crane's boom consists of a few sections sliding one into another. How do we calculate loads and strength of the boom sections? Running FEA on the entire structure takes hours of computation, which often fails due to bonding errors or provides inaccurate results because of very coarse mesh. Another reason of avoiding this method is that any change in part of the model costs you recalculating of the entire structure. We can make it more efficiently and more accurately by combining analytical methods for the structure and running FEA on individual elements afterwards. Why don't you try this? The lifted weight generates moment around the supporting point, which is the bottom sliding pad, and it equals the force FL multiplied by outstanding length L, and sinus of the angle beta, which is 90 degrees minus the boom angle. This moment is balanced by the top sliding pad reaction multiplied by the length of boom's overlap. Sinus of the force angle is ignored as it equals 1. From this equation, we calculate the top pad reaction R1, which is perpendicular to the boom. Next, the sum of all the forces projected on direction Y, perpendicular to the boom, must equal 0. This means force of the lifted load minus FL times cosinus alpha minus R1 plus R2 equals 0. From this equation, we can easily calculate bottom sliding pad load R2, and it depends on the angle of the boom. Using same principles, we can calculate other sections of the telescope. Note that the sliding pad's forces act in the opposite directions comparing to the other boom section. Unlike the very end section, on every next section right end, we have two forces of sliding pads contact. Again, we calculate top end pad load R3 from balance of bending moments, and bottom pad load R4 from balance of all forces projected on direction Y, perpendicular to the boom. Based on these principles, InBeEuro have released calculation tool that also takes into account the boom dead weight and box section strength index, and calculates full graph of bending moments and stresses along the box sections. You can also easily calculate the boom stresses at any angle and extension of the telescope, load on the lifting cylinder, and loads on slewing bearing, and ultimately, you can select the bearing or drive suitable for your application. Free of charge Excel files are available to download from InBeEuro website.